do. Okay, let's try it again. Okay, I had to go, that's why those were, okay? Anyway, 1, 2, 3, 4, 5, 6. You see that? Now, why are there 6 elements in the P block? This whole thing is called the P block. Why are there 6 columns? You put 1, see? You can put 6 electrons, 2 in each one of these, right? You can put 2 here, that's these 2, 1, 2, S1, S2, P1, P2, P3, P4, P5, P6. Yes? So without memorizing it, you can say, give me the electron configuration for fluorine. Okay, ready? 9 electrons. Watch. I'm going to read the periodic table. Tell me where all 9 electrons are. Here we go. 1s2. 2s what? 2. 2p1. 2p2. pp3. 2p4. tp5. I'm done. I'm reading the periodic table. Okay? Now, when I get to here, that's very special because I have 2 in the S and 6 in the P. And if you have 8 in your outermost energy level, you're stable. You do not want to gain. You do not want to lose. You don't want to react. You don't want to form compounds. That's what I call the noble gases. When I was your age in high school, nobody ever called them noble gases. For about 100 years, they were called the inert gases. What's inert mean? Do you ever see something like you take, I don't know, some like aspirin or something, and it'll say it contains 0.1% acetylsalicylic acid, 99.9% inert ingredients. Whoa, what's that? What am I putting in my body? Something that will not react with your body is inert. Anyway, these are called inert gases. When I was your age, you guys call them the noble gases. They don't want to form compounds. They don't want to react. And what's interesting is kind of like, wow, what an irony. All right? The secret to why everybody else wants to react came from the group of elements that didn't want to react. If you put 2 electrons in the first energy level, you'll stop reacting. So what is lithium going to do? I have 2 in the first and 1 in the second. Why don't you lose 1? Why would I want to lose 1? If you lose an electron, you'll have your 2 other electrons like helium, and you'll stop reacting. But if I lose 1, I'll become a +1 ion. That's right. Lithium always becomes a +1 ion in a reaction. Always. What about you? You have 4 electrons? What are you going to do? Well, what if I lost 2? Well, then the 2 remaining would be like that, and yeah, I'd stop. And so this group here always loses 1 electron. These guys always lose 2 electrons. I get it. I get it. Okay, now let's go on. So something I haven't told you about yet, and that's where we're getting a little more detail here, is, did I give you this packet? Does everybody have a packet like that? Okay. Now, I'm not asking you to memorize this chart, but if you're kind of a person who likes to look for patterns, then you could look at it. Let me show you how to read it. What's the electron configuration for every hydrogen atom's electrons? 1 in 1s, 1. How about helium? 1s, 2. How about lithium? 1s2, 2s, 1. And so this is just a chart telling you where the electrons are. You get it? Now for some of you, you'll see that and say, well, I'm not going to have to memorize that. Fine. But some of you are going to look for breaks in the pattern. 2, 1, 2, 2, 2, 3, 1. 2, 3, 2, 2, 3, 2. I'm sorry, 2, 2, 3, 2, 2, 4, 2, 2, 5, 2, 2, 6. That pattern looks like it's working. How about this one? Going down here. All right, pattern. 1, 2, 2, 1. I get it. I get it. I get it. I get it. And all the way to argon. All the way to argon, the pattern is really good. The pattern is really good. So what I'm going to do, I'm going to show you something that happens here. And these right here are called orbital diagrams. Now, I've seen some books that draw the orbital diagrams in circles. I see them use circles. Your book tends to use rectangles. I don't really care. I don't care if you use circles or rectangles. As a matter of fact, here's what I might do. Draw the electron configuration for nitrogen. I'd go like this. I'd say 1s, 2s, 2p, okay? And as a matter of fact, maybe I don't feel like making boxes. I'll just make lines. Got it? How many electrons do you find in every nitrogen atom? Everybody look at it real quickly. How many? Everybody. If you can't tell me how many electrons are in a nitrogen atom, you're in serious trouble. Okay, what is it? 7. Is that right? 7. Now, where are you going to put those 7? Now watch what I'm going to do here, okay? This other person, his name was Pauli. It's called Pauli's exclusion principle. Now, I didn't get famous discovering this. Somebody else did. Somebody else did. And here's what they found out. If you want to put something in an s orbital and you want to put 2 electrons in there, you'll see this in the book. You'll see them do like arrows. Now what he found out was, and I'll do a little physics with you here, okay? If you have an electron that's spinning, and it's spinning one way, anything that has a charge to it, it's spinning, will make a magnetic field. I said, I didn't know that. And anything that has a charge to it, if it's spinning, it'll make a magnetic field. Matter of fact, if I hook a wire up to a battery and let electricity flow through the wire, you know what it'll create right around the wire? If I had a little tiny compass and I lay it next to that wire and electricity's going through it, it'll make the compass deflect. Moving electrons cause a magnetic field. Matter of fact, Michael Faraday helped discover some of that. And so what I need to know is this guy named Pauli said that if you want 2 electrons to be in an orbital, you can't have them both spinning clockwise. They just happen to make the name clockwise. I hereby declare that that's clockwise. Not clock, get it? Clock. Okay. If you're spinning this way, you're clockwise. I hereby declare that up arrow means clockwise. Okay. And what if can I put 2 clockwise electrons in the same orbital? No. They'll kick each other out. He said, if one's spinning clockwise and one's spinning counterclockwise, they can both be in that same orbital. Okay, so good. So here's how I fill out nitrogen's electrons. Ready? 1s1, 1s2. You're spinning clockwise, you're spinning counterclockwise. I got it. Now I'm going to go into the second level. Where am I do it? Clockwise? That makes sense to me. I need your attention now, because I'm doing something I've never done that so far. Now, another person, and it better be written in your book somewhere, because every year I've asked people to write that person's name in the book. And it's called Hund's rule. Now, I also didn't discover this either. That's why, I'm not in every chemistry book. My name's not in the chemistry book. But here's what Hund decided. He discovered. When you get into a p, the p orbitals, okay, this is the same amount of energy as that. It takes a little bit more energy to be in a p than it does in s, a little bit more. And here's what Hund said. You have to put 1 electron in each p orbital before you can go back and pair them up. Okay, so let's try it. 1s1, 1s2. 2s1, 2s2. 2p1, 2p2, 2p3. Now, how many is that? Is that 7? That is how we think nitrogen's electrons are arranged, the configuration. You okay with this? So how many total electrons? 7. How many valence electrons? How many valence electrons? Outermost energy level. How many? Come on, I need some more help, okay? How many valence electrons? Raise your hand if you know. All right, how many? Jonathan? 5. What's the Roman numeral right above nitrogen? 5. I knew that. That's what that means. You have 7 electrons, well, 5 of them are valence. Where are those valence electrons? You got, they're right here. 2s1, 2s2, and then 2p, 1, 2, 3, and they're each of them in different orbitals. All right, so this is called an orbital diagram, and that's what you see. When you look in a book, they have a 2 or 3 or 4 pages of orbital diagrams. So if you look tonight, you say, I'm going to look at those things right there. So we're going to just spend a little time with that. All right. Now, what if we did another element? What if we did an element that, let's pick another one. Let's go to the next level, okay? Is everybody okay on level 1 and level 2? Level 1 only has S. Level 2 has S and P. What's level 3 have? What do you think? S, P, and D. It's got S orbitals, P orbitals, and it has 1 S orbital, 3 P orbitals, 5 D orbitals. Let's try it again. 1, 3, 5, 7. Get it? 1 S orbital, 3 P orbitals, 5 D orbitals. What do they look like? They're weird. Okay, if you thought the P orbitals kind of like dumbbell shapes, look at these right here. Wow, that's pretty weird. Those are called the D orbitals. Look at that other one. It looks like you had like a pacifier for twins or something like that. See that? That's kind of weird, isn't it? Okay. Anyway, I didn't make these shapes, but they discovered these probability zones. They call them D orbitals. Now, remember any D orbitals in the first energy level? No. Energy level 1 only has S. Level 2 had S and P. What's level 3 have? S, P, and D. Uh-oh. Let's go back to my chart here. Here we go. Level 1 only has S. Level 2 has S and 3 Ps. Level 3 has S, 3 Ps, 5 Ds. So the question I always ask on a test or even a quiz, I'll say, how many orbitals are in energy level 1? 1. So how many total electrons can be put there? I gotta have a little bit more eye contact here. I gotta know what's going on here. Energy level 1 has only 1 orbital. And you can put 2 electrons in an orbital as long as they have opposite spins, all right? So what's the total number of electrons that energy level 1 can hold? 2. Let's go to level 2. It has an S orbital and 3 different P orbitals. How many orbitals are in level 2? 4. Isn't that right? Each orbital can hold 2. Total number of electrons for level 2 is 8. Now let's make the jump. Level 3, it has S, 3 Ps, 5 Ds. How many orbitals are in energy level 3? Let's see, 3, 4 plus 5, 9. Each orbital can hold 2. What is the maximum number of electrons that the third energy level can hold? 18. Now, I'm going to show you something, okay? I know why there are 2 elements in period number 1. You can only put 2 in the S orbital, 1s1 and 1s2. I know why there are 8 elements in period 2. It only has S and P. 2 in the S, 6 in the P, right? Huh, easy. But here's something weird. You just told me, or I told you, energy level 3 has how many orbitals? 9 orbitals times 2, 18. How many elements should be in period 3? How many? How many should be in period 3? 18. Uh-oh. Let's try it. 3s1, 3s2. You with me? 3p1, 3p2, 3p3, 3p4, 3p5, 3p6. Are you with me? I know where 8 of those 18 went. But you know what? I should see more elements here in third period. But here's what's weird, okay? The 19th electron should have gone where? You put 2 here, you put 6 here, you should have put 10 in there, shouldn't it? They should have gone to d orbitals. Well, first of all, I know that's not true. Because where is the 19th electron? Where is the 19th? I know where 18 electrons are. Same place that argon put them. Where's the 19th electron? The periodic table tells me I am in the 4th energy level. What are you doing there? What are you doing there? You didn't put electrons in the 3D yet. What did you do? I didn't do it. But they discovered that the 19th electron will not go. It's easier to be in the 4th energy level in an s orbital than it is a third level in a d orbital. It takes less energy. And then when they made the periodic table, that's why they had to reflect that. So the 19th electron should go in 3D, but it doesn't. It goes in 4s1. And what happens to the 20th electron? Tell me, look at the periodic table. Where's the 20th electron? What do you think, Ty?
Like what?
I'll give you a clue.
Energy level? So 4s1.
It's in the fourth period, so you say 4,
4s2.
and it's in this block. See these two rows here? That's called the S block, so it's going to be S,
4s2.
4s2. What are you doing? You just put 2 in the 4s, and you still haven't filled in the 3D. And then you see another part of the periodic table we haven't even talked about yet. We start here. Look at this. Start right there at scandium. What'd you do with your 21st electron? You're not in the S block. You're not in the P block. What is this? What is this going to be called? What's this called? Anybody know? The D block. The 3rd energy level can hold 10 more electrons. But the 19th electron doesn't go there. God said, I want it to go there. In the 4s1, and the 20th electron, I want it to go in 4s2. But look at number 21. Guess what number 21 is? Nice where you have to pay attention, okay? Where do you think that goes right there? I'll give you a clue. It's not in the S block, and it's not in the P block. It's in the D block. 4D? No. Which D? 3D. You subtract the number, don't you? 4s1, 4s2, 3d10, 3d1, I'm sorry, 3d1. Okay, here we go. Hang on to your hats. Here we go. Ready? How many d orbitals are there? How many? 5. That's 10 electrons, right? Here we go. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why there are 10 elements in that block. You going back, and yeah, you put 4s1, 4s2, then you went back to fill in the 3, 3d1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In a perfect world. In a perfect world, that's what would have happened. And just like Hund's rule, they would have put 1 in the D, another one, another D, another D, right? Clockwise, 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 doing that. Then they would have gone back and paired them up. All right, so what we see here is that it seems to be easier to put an electron in 4s than it is 3D, because I did 3s2, 3p6. I did all those, but then it took too much energy to go to 3D. So I put 2 here, and all of a sudden now I'm ready to go back and fill into 3D. And so that's what this is. This is a D block, okay? This is the D block. All right, so what do you think? So let's try it. If you have a piece of paper somewhere, your notes, let me see you write out the electron configuration for scandium. What's the electron configuration for scandium? So let's try it. Let's see. Davis, you're going to help me out, okay? All right, Davis, here we go. I'm going to do an orbital diagram, and everybody else can do your regular configuration. We have 1s, 2s, 2p, 3s, 3p, Oh, ran out of space. All right, so here we go. Ready? Scandium has 21 electrons, and all you have to do is say 1s clockwise, 1s1 clockwise, 1s2, kind of, what do you want to do? Where are the first 2 electrons going to go? Clockwise? And counterclockwise? Okay, what are you going to do then? That's 2. You got 19 to go. Say up, down. Want to do that? 1s2, 2s2. Hund's rule. Yes. Wait a minute. You know why? You know how I know he's at a noble gas? How do I know he's at a noble gas? Anytime you have 2 in the S and 6 in the P, you're going to be noble gas, except for helium. He always had 2. All right, you're doing a great job, Davis. Go. Ooh, how many you got there? 10, 11, 12, 13, 14, 15, 16, 17, 18. You only got 3 more to go. Here or here? Yes, look at the periodic table. The next electron goes in 4s1. How about the 20th? All right, so if you were to go up here and look at this periodic table, you would actually see written under scandium, and it would say 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. What's this one? What's that last one? 3d1. Okay, now, so here's a way on a quiz you do it. You say 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d1. Now, many companies do not like seeing the number 4 written before the number 3. So some companies will say 3p6, 3d1, 4s. My fault. I don't worry about that. I won't count off for that because I like you to do it the way it was kind of filled. But a lot of periodic tables, and including your author, he'll say 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. That's not the order it went in there, but they don't like to have the 3 come after the 4. So they don't worry about that, okay? All right, now, for those of you, remember shortcuts? You like shortcuts, don't you? All right. If I say you're allowed to use a shortcut, I will show you a shortcut way of writing this right here. What you do is, what is the noble gas in the period before scandium? Okay. Here is a shortcut. It's called the noble gas shortcut. Noble gas, they actually call it configuration. And so here's what you do. If you put argon in brackets, guess what you're going to do? That's what you do with your first 18 electrons. You put your first 18 electrons like argon did. That's right. I did. Well, how many's left? 3. Well, then tell me where the 3 other ones are. Okay. And again, some companies will say 3d1, 4s2, like this one. Everybody see that? Ooh, I like that shortcut thing. I like that shortcut thing. All right, you okay? All right, now, what I'm going to do is okay, now, did you guys have this in middle school? Did anybody do electron dots with you? No? Okay, I'll show you real quickly. If you have an element, such as element X, I just made that up, what you do is, it's kind of like the shortcut, except what you do is you only show valence electrons. You only show valence electrons, okay? Now remember, nobody ever has more than 8 in their outermost energy level. You'll never put more than 8 dots around any element. So what I'm going to do is, let's do an electron dot. Let me show you how this works. Some books, they like to start at the top. I like to start on the right. First electron goes here. The first 2 pair up. The 3rd, 4th, and 5th electrons do not pair up unless they're forced to. And then 6th electron goes here, 7th goes here, 8th goes here. So I have no idea what you just said, Mr. Feeney. That's fine. That's why I'm going to do some examples. Ready? Let's do sodium. Sodium. What is sodium's noble gas configuration? What's the noble gas before sodium? Okay. If you do that, you just told me that the first 10 electrons went like that, like neon did. What's left? What's left over? Look at it. Look where it's at on the periodic table. Where's the 11th electron? Where's the only valence electron? Anybody get that? Now let's do electron dot. Electron dot. How many valence electrons do you have? 1. Where are you going to put it? There you go. Anybody have an idea what the electron dot for hydrogen is going to be? How about lithium? How about potassium? Rubidium. Wait a minute. Why do they all have 1 dot? Because they all have how many valence electrons? 1. And you know why it's by itself? Because there's only 1 there, right? Let's do another one. Look, let's do magnesium. What's the shortcut for magnesium? Help me out, Elizabeth. What's the noble gas shortcut for magnesium's electrons?
Put 2 dots on the side.
Yeah, but what's the shortcut, like this guy?
Like the one before it.
Yeah. What's the noble gas before magnesium?
Sodium. Neon.
Noble gas. Where noble gas is that?
On the far side.
There you go. So what's the noble gas before magnesium?
Neon.
If you put that in brackets, you're telling me neon had, I know that magnesium had 12 electrons, but guess what? The first 10, same place neon put them. All right, Elizabeth, how many are left over?
2
Where are they?
on the side.
Yeah, like where? No, not the dot yet. Here's the first 2 electrons for magnesium. You got, how many more do you have?
3s.
Is magnesium in the 3rd period?
Yes.
It is. Is it in the S block?
Yes.
Okay. Is it S1 or S2?
2.
So what are you going to say?
3s2.
That's what I thought you'd say. Now, so here's my abbreviation for all the electrons. Now, you ready? I'm going to do electron dot. Where am I going to put them? Without looking at Kayla.
2 on the right side.
Okay, and you know why you pair these up? Why do you pair them up? Why did I say you pair up the first 2 and the next 3 you don't unless you have to? Who knows that? What? Say it again? I can't hear you.
That's how the orbitals work.
All right, keep talking.
Like in the P's, how when you're drawing the arrows, you only draw up. You draw them up until you.
Okay, all the valence electrons are either S or P, aren't they? Aren't they? When you do that, when we went up here, what did you always do with the S? You went up, down, didn't you? The first 2 pair up. But then you get into P orbitals. What happens then? You don't go bum. You go like this. Ba-da, ba-da, ba-da. You don't pair up the next 3 unless you what? Unless you have to. Well, that's what this is all about. This is all about S and P. This is your S orbitals. These are P orbitals here. So that's why the first two pair up, the next three don't, unless they have to. All right, catch on this? All right, let's do Noah, wouldn't. No, give me the shortcut configuration for let's do nitrogen.
Helium.
What's the noble gas before nitrogen?
Helium.
All right, that's 2 of your 7 electrons. What did you do with the other 5?
2s2.
Yes, yes.
And then 2p3.
2p what?
3.
Okay. Yes. Very, very good. You're reading the periodic table, right? You're learning how to read it. Now here's the hard part. Noble gas. How many valence electrons do we have?
5.
Where are you going to put them?
Okay, what do you need?
I'll start on the right. You want them here? You want the first one here? Where do you want the next one? When you do electron dot, do the first 2 pair up or not?
They do.
They do, because they're in the s orbitals. Then what?
Then next 2 pair up.
No. The next 3 don't pair up. You know why? You know why they don't pair up? Because you put 1 here, and 1 here before you pair them up. That's Hund's rule, isn't it? First, in one p orbital, a different p orbital, a different p orbital. So are those 5 dots here?
No.
No? Oh, can you see this? Are those 5 dots?
No.
And you said there are 5 valence electrons, right? There we go. Matter of fact, everybody in this whole column is going to have 5 dots. Everybody in this column is going to have 6 dots, 7 dots. Except for helium, he's going to have 8 dots. All right, what do you think? You want to make it? Can I do some hard stuff? Let's do some hard stuff. Let's do some hard stuff. We got about a few more minutes here. Okay, let's do this one. All right, John, give me the shortcut electron configuration for potassium, the noble gas shortcut.
It's argon.
That's 18. How many electrons do you have? 19? What are you gonna do? Where's it at?
4s1.
There you go. How about the, let's do the electron dot.
Just 1 dot.
That's right. That's pretty easy. Keep going, John. Now do this one. This one had 19 electrons, right? How many does this have?
1.
How many? You know why he's +1? Why do metals form plus ions? Because they lose negative electrons. This guy lost an electron. That's why he's +1. How many electrons?
18.
Okay, now, you can't just put argon in brackets. Now, what's the noble gas before that?
Neon.
Okay, there's 10 of your 18. Where's your valence electrons now? That's 10. You got 8 more. Where are the outermost energy electrons for this guy? And he doesn't have that one anymore, so he can't. That's not his outer. Wait.
3s2.
If you had 18 electrons, where would you put them?
P.
If you had 18 electrons, where would you put them? You put them like argons, right? Argons would be, the first 10 would be like neon, and then, see that? So how many electrons of this guy would be in the outermost energy level? 8. First 2 pair up. The next 3 don't unless they have to. Oh, now I have to. Okay, and real quickly, we'll do one more. Let's do argon. What's the electron configuration for argon? It's neons, 3s2, 3p6, and I did it wrong. 1, 2, 3, 4, 5, 6, 7, 8. There you go. And notice that. Why does potassium want to lose an electron? Because then his valence electrons would be just like the noble gas right there. Okay. Yes.
I thought argon didn't have valence since it was.
Well, they're valence, but they don't want to gain or lose any more. So, except for helium, all noble gases will have 8 dots around them. Good question. All right. I'll tell you what we'll do. I won't see you till Wednesday. I would work on some of the homework questions. You really, really don't want to wait too long on those. Thursday night is not the day to do all the there's like 70 of them. So if you did none of them last week, you said, I got to sit down and do about 20 of those tonight. They go pretty fast. All right, well, thank you very much. I'm gonna go to maybe Walmart, get me another 297 laser. I can't even believe it. When I was younger, it cost like $40 for a laser. Now I can get one for like $297 at Walmart. I wanted a laser so bad when I was younger, but there's no way I had that much money.
Mr. King, will our quiz like have this on it on Wednesday? Like, what is it gonna be on? Is it gonna have like problems on it?
Well, it has, for example, it talks a little about waves and wavelengths. Remember that? And quantum jumps. It has I think there are 3 scientists on there. It does have electron configuration, where you just go and do the regular configure, 1s2, 2s2, 2p6. It has that. I might have a couple of those on there. And the orbital diagrams, all you have to remember is that you go up, down, in S, up, down. But P, you have to put 1, 1, 1, then you put another in there. Same thing with D. You would go 1, 1, 1, 1, then come back, pair it up like that. So. Bye-bye.
I've seen you all day. How's it going? Oh, what did you do? Can we talk? I just said his own. Victoria, I can teach you how to look through.
Oh, wait, can I see your thing?
Wait,
Yeah, I'm just asking you so I may understand.
did you take one? I'm doing it for extra credit. Pete, you gave it to me. I'm doing it for extra credit.
Can I do the extra credit that Madison's doing, like look at different lights and then show the?
What this person did is they did 5 of them, but I told them I thought that for sure they'd do one at the gym, so I sent them down there. But what they did is they drew the box ahead of time, and they happened to, I guess they had it upside down or whatever, but they went 4, 5, 6, 7, 8. You could do that way or this way. Matter of fact, you won't go past 7. Visible light's between 400 and 700 nanometers, so all your colors are going to be between 4 and 7 anyway.
Okay.
So you can make your own little boxes ahead of time. Now what he did is he looked at his iPhone. And you notice the iPhone gave one very close to C600, 680 maybe 650. So he drew a red line, and he noticed a whole bunch of greens and a series of purples. Here was a ceiling light. He wasn't sure what kind of light bulb it was. Here's his TV. And then flame, he did a flame, like a regular lighter.
Yeah.
And he noticed it gave a continuous spectrum. And then he went to the gym and saw there were certain lights. He just did that one today. So you could do some interesting things. You could do a car headlight, a dingy car looking headlight, bright headlight, different lights in a grocery store, like where the meat counter is. You could do go to a neighborhood that has really bright street lights versus a neighborhood dingy looking street lights. The gym has
Do
mercury
you want me to
vapor.
go to the gym? Like, is that specifically a thing?
I like that one because most people don't know. They don't know those are like special light bulbs or mercury vapor lights.
Oh, okay.
A lot of street lights, the dingy looking ones, are called sodium vapor. Neon. You can go to Hot Now signs. You can go there. You can go any bright colored sign. Like,
Ooh, I have a lava lamp. I could do a lava lamp.
I'm not sure what would happen there because it's not like you're not really exciting. It's actually a regular light bulb reflecting off some. So you could try a lava lamp.
Yeah.
I don't think you'll get anything, but maybe.
Okay.
But if you went around town and saw a light and it was really bright and it said discount or whatever, you could try it. And if it was blue, maybe it was like argon makes purple. Neon looks orange. I don't know. Just use your imagination and say, I'm going to keep that in my car, and then when we're driving around.
Could I borrow one of
Yeah.
these? Because this is Madison.
Oh, okay. Here's I'm going to put your right name down. Amen. Okay, so just go get a different one, and then and let her do that.
I got every single question right except the way she didn't let me finish. So I'm so mad. I'm so mad. Yes, I tried like 3 times. I got my mom to call Mr. Shore, and she was so like, and she was still like, no. She's killing myself the way she was like, I'm so mad. I'll text my mom.
Hey.
I'm gonna finish up our project. Is it cool if I work in the back, or should I go to the party?
You can do that. I mean, they're gonna have a lesson, but you'll be. I mean, if we don't bother you, it's all right.
Okay. And then also, I have my test. Finished it Friday, but I forgot to turn it in. And Carson's, I think, is over there too.
Okay, I need the test, and then you turn in your book when you're done. Also, don't forget to turn in your book. Otherwise, I'll charge you for a book.
I'll bring it tomorrow. It's at
Okay.
my house.
All right, and then by the end of this week, I have to turn in anybody who owes money or something like that. So give me your test as soon as you can, and then if you can finish that report today, that would help me out. But if not, I'd be okay to give me the chromatography tomorrow.
Okay.
Yeah.
Thank you.
Do everything as fast as possible.
It's just so frustrating. It's like, dude, I get it, I'm the only one who didn't finish, but number one, the classes were shorter.
Yes.
Yeah, like, we didn't get enough time, even though everyone finished, I still didn't have the amount of time that I usually have, which I'm accustomed to. Number two, it's just 2 problems, is they're really bad, they're gonna be able to let me stay.
It's not like a page.
To let me stay like an extra 2 minutes to finish my 2 problems. So like, look, I got every problem right, except for the one she didn't let me finish.
How many problems is this one? 10 problems.
Use
It's a lot.
Carson's.
You have his test?
He left it here. He was here this morning.
Okay.
And he just said he left it under there. And then
Okay.
mine.
All right, so thanks. Now I need, besides his answer sheet, I need his test also. See, if you see him, tell him he needs to give me the test and the answer sheet.
I'll let him.
You missed, my problem is I go too fast, I miss major stuff. I miss like,
Kyle, on that last table back there, on the left-hand side, Calvin left his stuff.
Did Tim bring his?
I didn't see Tim.
He said he was gonna bring it, so I don't know.
Well,
Oh, gosh.
if you have a chance to call him, because he's been known not to even turn in homework, so
Alright, I'll find out.
you could call him and say, Tim, you said you'd have this done.
It's like,
I think maybe Calvin turned it in for him because
Oh,
That's, I think what we needed.
really? That's it? That's all he did?
Um,
That's all you wanted him to do?
Well, no, he did. So I printed out. He did all the vocab and stuff. And I printed that out. But this is the only thing that wasn't online. I could
Okay.
print out.
Very high A.
So,
I know you'll hear that when you came out of that class. I was so bad. I wear it several times.
You need like a clip, a binder clip?
yeah, probably the best.
Yes. Yes.
All right, I think it's all there.
Okay, all right. All right, well, thanks. When do you give your thesis?
I don't go till Friday,
Okay.
which is good and bad. I'll have time to.
Watch other people?
I'll have time to practice, but I kind of want to get it over with. So.
Yeah, I always hate that too, because if you already see 3 other people and you said, oh gosh, you know,
Yeah.
but maybe you'll see somebody that wasn't as quite as ready, said, I can do better than that.
That's
So
true.
you never know.
That's true.
But you're right, I'd rather get over with if I could, but that means you'd have to work a lot this weekend.
Yeah. Middle of the week probably would have been the best for me, but
Okay. You'll do all right. You'll do well. Just practice. So just get in front of, give it at least 3 or 4 times. Even if you only do the beginning 5 times. So do the beginning, and once you get off to a good start, then you'll be confident, and you'll remember that you have notes, right? You have 1 page of notes?
yeah, we have 1 page.
But I would definitely, I'd practice all the way through 2 to 3 times. And then I'd practice the beginning a couple more times so that you feel confident at the beginning.
Yeah.
Once you get off to a good start, I think you'll be all right.
Yeah. It'd be interesting for sure. Thank you.
All right, bye.